Welcome to Re-Security Maths. Today we are gonna see how we can write a program using our continue extension, and in this extension we will use the Gemma4 agent to write a Python program which uses AES 128 and uses elliptic curve signatures to sign the messages. So first of all, we write the program, right? So what we do, first of all, we use the files and file tree, and then we write a Python program inside the folder, inside this folder, which uses AES 256 to encrypt text messages, and I hit enter over here. Let's see what the continue extension do. If you see closely, it is saying that there is a Python file add numbers.py, but it has to create a new file which is AES encryptor.py, and now it is creating the create AES encryptor.py, and now it has generated the Python file to encrypt using AES. And what we do, we just accept it so that it creates that file. And this I think we don't need this notification, and this has written the Python file. We are using AES to encrypt and AES to decrypt. Alright, so here is the original message which we want to encrypt, and then it will encrypt and then it will decrypt also. But there is one problem. If we try to run this file using the Python, it will give some errors because we haven't installed these libraries. So what we will do, we will ask the continue to tell us that which libraries do we need to install. Tell me which libraries should I install using pip for this Python, for running this Python file. Okay, for running this Python file, and then I will hit enter, but I will give it a context, and which one is the file? The file is aesencryptor.py, and I will hit enter. So it is saying that I should install pip install cryptography. If you don't remember how to create virtual environment, you can ask it also. How to create virtual environment, and it is giving you the command. So the command is python 3 mvnv, and this is the name of the virtual environment, mynv, and then we will activate this virtual environment using this command source vnv bin activate. Sorry, the environment name was mynv bin activate, and now we will install pip cryptography. And now we will try to run this file, and you see that it has encrypted the message using AES 256. But we are not done yet. It is asking us to enter our own text for our user interaction. So we can type the text hello world, how are you, and hit enter. So it has given me the encrypted text in this form, and then it has decrypted the text also. Now what I will do, I will add a functionality to this file. The file is AES encryptor. Add functionality of hashing and then digitally signing the encrypted text using ECC, elliptic curve cryptography, and I will hit enter. Now it will take some time, and it will write a program, and it will somewhat extend this program. So it will edit this file to add the 2 or 3 these new functionalities. Now it is first defining, it is defining the plan to update it. Okay, so now it is applying the changes. Okay, so it has given some errors. Continue tried to edit AES encryptor. I think there has been some problem. We can stop it and write it again. So first of all, the add functionality of doing SHA 256 hash of the text we are encrypting, and I will write the context of AES encryptor.py and hit enter. Actually, these problems sometimes arise because ultimately it is working on my laptop only, Gemma4 model, and as it is running on my laptop, there could be several problems because the processor may heat up or any other things also. So therefore there may be some problems, but I think it will overcome it and give us the correct output. So let's wait for some time. Now it is saying that continue will edit AES encryptor.py. File path and changes arguments are required. Please try something else or require further instruction. Okay. So there was problem, and as it is in the agent mode, so it is using the features again, and it is using some library import and calculating the original hash of the original message. And this is the beauty of agentic AI, because it is using agent mode and not in the chat mode. So it is using agent mode where all of the editing this continue extension is going to do. And now you can see it is applying the changes. And one more useful property of this kind of workflow is that your data remains completely on your laptop or machine, and it never leaves your computer. This whole process is being done using the Gemma4 model inside our laptop. Okay, so now it is asking for the changes. I will click on accept all, and now it has done some changes over here. And now if I will run it, it is giving me the user interactive mode to enter the text. And one thing you will notice that for the original message, it has already computed SHA-256 hash. So what I will do, I will enter text to encrypt, and I will again enter the same text, hello world, how are you, and I will hit enter. And now it has given me two things. First of all, it has encrypted the text, and then it has given me the SHA 256 hash of the value, and then it has decrypted. Okay. Now it is asking me what would you like to do next. We could proceed with implementing the digital signing with ECC, reviewing the code structure further, running the script to test the new functionality. So I will ask it to implement ECC digital signing in this Python file. Okay, and one thing I will also write, but I will do it afterwards. I was going to write for verifying, but verification we will do afterwards. First of all, let us do this only, and we will give it the reference of the file aesencryptor.py, and we will hit enter again. Now it is again generating, and let us wait for some time so that it does its work and give us the required output. It has created a plan that first of all it has to import some specific modules, then it has to generate key pair, and then it has to write signing function, and it has to then update the main function. And now it is editing the aesencryptor.py program. We are using the AI model offline on our laptop, but if you want to use some online model, you will get the results comparatively faster than what we are doing here. And now again there was some error, but it is still generating. It will, I think, rectify the error itself only. So what was the error? Again the file path and change this argument. So we will leave it for some time, and it will then again come up with a plan to rectify all of these errors. And it has now written the plan, and it is writing the complete program. And if you see in this Python program, there is some code like generating ECC key pair and then signature. Okay, and now it is writing some helper functions. Then there are some core logic functions, and now it is the main execution block. I think we have given it a very difficult task to do for now, because improving a program and adding more functionality is a little bit difficult for it. And if we look at the aesencryptor.py function, sorry, my program, there has been no addition of um, ECC. So what I will do is ask it to apply required changes to this file as you just did for adding ECC signing and verifying functionality. Let's see what it will do. And we can do one more thing. Okay, so it is giving us the option to apply the code as well. Alright. I think we did some mistake. So I will, with the code structure, we can click on this apply code, and then it will apply all these edits. Let's see what it is doing. So it has just given me a plan, and after clicking on the applying code, according to me it should add this code to the main file. Yeah, it is writing that continue will edit AES encryptor.py. See, it is taking a lot of time, so we can do one more thing also. Instead of asking it to edit, it has given us the required programs. So what we can do, we can copy all of this code and then just below this we paste it. Now most of the imports are already there which are above it, and but it requires some of these extra imports, so let it be. Okay, and after that these are some functions to sign, and what we will do at the end, process data with verification, sign data. Okay, we have this executing block, so we can copy this code and we can paste it in our main program after this. Alright, so if name equal to main, we will select it and do like this. But there is still one problem, and the problem is that we haven't defined these functions: process data with verification. So what we will do, we will go a little above and we find that these functions are defined here. So it is making some of uh, the, I say, mistakes, but we can copy and paste this code, and these are the functions, so it should be they should be written below this before the main function. And how are they going to be defined? First of all, it should be written like this: simulates the process, then this is the comment only, then we will print it, then signature, then again there is print command, and data to sign, private key, and then what we do, we return the signature. But all of them must be in the program itself. Okay, I think, yeah, now it is working fine. Similarly, we do it with the process data with verification, and after this we hit enter, then we enter the print command, then we have this try, and the after the try there must be an indented block, and this is public key verify. But after that we have print, and after that we have return true, and then it is accept block, accept exception, and then again we hit enter, and after that we hit enter, return false. So these are the programs, and now what we will do, we will try to run it and see if there are any errors. If there are errors, we will do something else. Okay, so there is, I think R is missing, return signature, and then we run without debugging. I will write just hello over here, and now it has verified the signature. But let us see what it is doing. It is doing all of this work for the main message which we were using here. So what we will do, we will first delete this interactive mode and just encrypt and decrypt the message from here only. So let's say that we have this original message, and we will delete this message and we will write it our own message. For example, we can write there will be no meeting tomorrow, and we then run this program and let's analyze the output. So first of all, it is the original message is there will be no meeting tomorrow. SHA-256 hash is this one of the message, and then there is the encrypted message in base 64 encoding. After that, it has decrypted it. There will be no meeting tomorrow. This is the decrypted message. Then we go to the ECC key pair. The key pair is generated successfully. The original message is this one. Then we sign the data, and then we the data is successfully signed, right? So it is successfully signed. Then we have the verification. So what it will do, it will verify the signature, and the signature is verified, verification is complete. And after that, it is doing some another testing where it is tampering the data and then verifying the signature, and then it is telling me that signature verification failed and data may be tampered with. Now let us analyze the code a little bit. In the code, this was the main, so this is the original message. Then the message hash is calculated over here. After that, the message is encrypted over here, the message is decrypted, and here we are generating the ECC key pair. After the generation of the ECC key pair, there is the original message, and then it is signing the data using the private key which was generated by the ECC. Now, verification success. Verification is process data with verification. This was the data bytes, this is the signature, and this is the public key. So we are using the same data, which is the original message. Okay, and now we are writing that if the verification is success, then we will write verification complete, and else we will write that verification was invalid. I mean that signature was invalid. All right. And next, what we do, we in the tampering test, they have written a text tampered message. This message has been secretly altered. So we have done some editing in this message, and we have tampered it, and then we are trying to check the signature over this tampered data using the public key, and we find that it failed. Now we will do one more thing. I will copy the text of this plain message that there will be no meeting tomorrow, and I will copy it, I will paste it here, and then let us check what is the result. Okay, so here is the terminal. Wait. Okay, the signature is valid, and on the other hand, it is telling me signature verification failed. Now, why it is writing the signature verification is failed? I think, okay, so it is telling me again and again that the message is not the same. Why it is so? I will try it again with this one, data bytes. So I will write data bytes, I will save it and run it again, and now it is saying the signature verification passed, data integrity confirmed. So I think when we copy the text, there is some extra information which is getting here. That's why it is writing that the data was tampered. But if I use the same data bytes, it is telling me that the message is same. So let's see the format. uh, okay, wait, I think there is some problem. Yeah, okay, the problem is that there are two encryptions. The one is the AES encryption, and after that the the ECC pair is generated for another message. So this was the problem. So this is the message for which ECC is being done. So what I will do, I will copy this message and put it here, and then in the data bytes, in the place of data bytes, I will write tempered data, and I will run this file. And now you see the signature verification has passed. It means that the both of the messages are same. Now I will do one more thing. I will change this tempered message, and I will just remove this full stop. So now the tempered message and the original messages are different, and then I will hit enter like running. And now just because there is the dot is not there, the signature verification has failed. It means that the data or the message has been tampered in between. So in this way, we learned in this today's video that how we can use the continue extension to write the encryption program. And the beauty of this extension is that we might not know that these libraries exist to make our work easier, but it has imported them itself. And however, there were some problems in between, like it was not able to write all of the program here. But if you work it with regularly, and if we improve our prompting skill, I think it will be able to update the functions inside of it. Okay, so I think for today it is enough, and we will um, do some more things. We will do some more manipulations, and we may try using some other AI models, some online models as well, for writing such programs using AI. And um, but one thing we must have noticed, that it is not necessary, that it is not sufficient to use AI only. We must have knowledge of the programming ourselves also, because if we don't know how the Python file is going to run, if we don't know how the functions in the Python work, this AI is not going to help. It may make mistakes, and there must be some human involvement which will correct those mistakes to generate the required result only. So let's meet in our next video. Thank you all.